Okay, I'm looking at standard 6.4e, the introduction page, and this is about converting decimals to fractions to percents. If I take a look at this bar model, this strip diagram is what we call it in class, I can see that it has three total parts of it, and one of them is shaded. So that is 1 out of 3. And we memorized our benchmark fractions. 1/3 is the same as 33%. That's what we called in class. So which fraction of the model is not shaded? Well, it'd be 2/3, which is 66%, as we call it in class. Or you could say 67%, because it'd be 100 minus 33, right? Really, we have to round, so either one of these would be okay. The real answer, if you remember, is the devil's number, 66.666666. All right. Anyway, it doesn't matter. Number 2, Mrs. Cupid surveyed her class to determine how many students ride the bus. The survey results show that 9 out of 24 students ride the bus to school. Represented as a decimal, what part of Mrs. Cupid's class rides the bus? Well, that'd be 9 out of 24. Got to make that into a decimal. So there's a couple different ways of doing this. We could divide using long division, 9 divided by 24. We could try to get to some power of 10, so maybe 100 or 1,000 or anything like that. We could reduce the fraction. I think that's not how I might do it. We could reduce the fraction, see if it reduces. And is there anything that divides into both 9 and 24? So you see, 9 doesn't go into 24. 9 is 3 times 3, right? So does 3 go into 24? Yeah, it does, right? So that would be, if I divide both 9 and 24 by 3, I get 3/8. And 3/8 is one of my benchmark fractions. So I have it memorized in my head that 3/8 is, as a decimal, is 0.375. Okay, how did I explain the answer? I simplified 9/24 to 3/8 by dividing the numerator and denominator by 3, then used, oh no, I can't read this anymore, my benchmark. Okay. Using the number line below, what percent of the distance from 0 to 1? Actually, I want to show you before I get onto that. I could use it in long division. So if I do 3 divided by 8, right? 8 doesn't go into 3, but it does go into 30 twice. No, 3 times. Sorry. 8 times 3 is 24. Remainder of 6. Should give myself more space to do this. 8 goes into 67 times. The remainder of 5. Sorry, remainder of 4. It goes into 45 times. So I get 0.375. All right. Number 3, using the number line below, what percent of the distance from 0 to 1 is represented by point C? So let's see, 0 to 1. How many places is it divided into? There's 1 place, 2, 3, 4, 5. So my answer as a fraction would be something out of 5. Point C is 3 of the fifths all the way there. So if I want to make this into a percent, I could have it memorized. Or I could get from 5 to some power of 10. Best would be to get to 100, because that would give me my percent automatically. 5 times 20 equals 100, so 3 times 20 equals the percent, 60%. Number 4, Reginald answered 78% of the questions on his social studies quiz correctly. So what fractional part of the questions did Reginald not answer correctly? Again, 78% is 78 out of 100. Yes. So if he got 78 right, how many did he miss? It'd be 100 minus 78, which is 22. So 22 out of 100 would be a correct answer. You could reduce that if you wanted, simplify it to 11/50ths. That would be your answer. All right, question 9. Shade the model below to represent 1/4. Okay, so that's going to be 1/4 of the squares. There's 100 squares, so if I shade in 25 of them, that'd be good. I'm going to shade in my fourth like this, because I feel like it. Okay, 1/4. What percent did you shade? I just explained that, 25%. Explain your answer. Well, 25 times 4 equals 100. Yep. Mitchell sold 56% of his baseball cards to buy a new bike. What decimal represents the part of Mitchell's baseball cards he sold? Okay, this is really simple, guys. To go from 56% equals 56 out of 100, yes, which is 56 hundredths. Right? Okay. Shade each model to represent the number as shown. So 4/5. All right, so right now I have, this is divided up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So I need to get, let's see, 4/5 would be how many tenths? Well, I double it, 5 times 2, so 4 times 2 is 8. So that'd be right here, I believe, 4/10. I'm going to shade it in. There's 4/5. All right, 2/10. So remember, this is 2/10 would be, each one of these is 10, right? So I'm going to model in 2 of them. 2/10. There. And 62.5%, which I know is the benchmark fraction, that would be 5/8. This is already hopefully an eighth. Yes, it is. So I'll shade in 5 of them. And I'll just be really clever with this one and shade in something weird.